So showing zero point 0.8 repeating as a fraction, we can do this using an infinite geometric series, and I'll show you how. So this fraction really is 0.18 plus 0.0018 plus 0.000018 plus ... and it's going infinitely. Well, this is, in fact, if you look at the progression of this sequence, the multiplier here is, I'm going to divide by 100. Okay, so I'm just adding a couple zeros, so I'm going to times by 100. So my R value fits the criteria for infinite series. It's less than 1, so each term is getting smaller. It is geometric because every term is being multiplied by the same factor. Okay, so this must fit our infinite geometric series. So if I use this in my formula then, so I know that the sum is going to be 0.18 divided by 1 minus 0.1 over 100. Okay. Well, what's that become? That becomes 0.18 over 99. Okay, or sorry, 99 over 100. And as a complex fraction, I'm going to bring that 100 to the top, and I get 18 over 99. And that is my repeating decimal of 0.181818. You can try that on your calculator if you want to simplify this fraction as well. This does simplify to 2 over 11. There's a common factor of 9. So testing this on my calculator, I go 2 divided by 11. Yep, that's my 0.18 repeating decimal. And I can show that by plugging it into my infinite series formula, because this is an infinite series, and I know the A value and I know the R value, so I can just plug that in. So this is some pattern. If I just kind of start shading from the outside in, notice that there's kind of a, well, there is a natural limit to this, isn't there? Okay, so I'm going to shade in there, etc. And I go in. Okay, so the total area is 100 centimeters squared, and there's no way I can go beyond 100 because I can't color outside that box. So what's the limit of this? Well, I can maybe find out the area of my starting value here. So that area, the A value, is 50 centimeters squared. Okay, because that's really the outside, the 4 outside triangles represent half the square. And what's happening for each time? Well, I'm essentially getting a quarter. I'm just going to look at one triangle here, and I'm going to, each iteration of this is 1/4 of the original triangle. So my R value must be 1 over 4. I'm getting exactly 1/4 each layer. Okay, and again, this layer, this inside layer here is going to be a quarter of this layer. Well, this must have a limit. It's an infinite series, and I can write it with my infinite series formula. It's going to be 1 minus 1/4. So when I work this out, this is 50 divided by 3 over 4, or 200 over 3. So it's approximately equal to 66.6 repeating. Okay, so this is, if I were to fill up this square, I'm going to actually fill up 1/3 of this square by using this pattern. So 2/3 of the square. So 1/3 of the square would be left white, 2/3 would be left, would become green, shaded green. So just looking back at that first infinite series, we could actually use the same kind of idea here. We're just going to, I can actually show you that essentially we're going to shade this full square. So let's say I start with that. That's my 20. Okay, and the next is going to be shade 10. Well, 10 would be half of 20. So there it is. Okay, and then I can shade the next piece here. Let's say that 5. Well, 5 is half of 10. So I can just take half of the remaining. 2.5 is going to be half of that, the 5. So it's going to be half of that. And we can go on, we can just keep going. We can just take half of the remaining, half of the remaining, half of the remaining. We'll never fill out this. And if this, we started with 20, the total area that we would shade would end up being 40. Okay, so this is another way we can show geometrically that this is in fact true. This infinite series does actually give us a finite sum. If visually there's no way I can go beyond the bounds of this 40 square unit a square here. So this is kind of a similar idea here, but this is, we're not shading the whole thing here, we're just going to end up shading 2/3 of it. Okay, so that's infinite series. Essentially there's just a formula. You just have to establish that it's a decreasing sum. Okay, the sequence is decreasing and we're decreasing to 0. If that's the case, we can use this infinite series, and we're going to infinity, we can use this infinite series formula. Okay, so some things that we covered this unit. Okay, sequences. Okay, we have Tn. Okay, we can find out the key things that we want to find out are R and A. Okay, the first term and the common multiplier. So in this case, if I want to find R, I can use that handy little formula where if I divide the terms, I'm going to get the number of times I use the multiplier. In this case, it's going to be 5. And that multiplier on R, not A. Okay, so there we go. So if I divide 288 over 9, that's going to be R to the power 5. Solving for R, I can just take the 5th root of that. So R is equal to, okay, the 5th root of 288 over 9. I'm getting 2. Okay, so that works out to be exactly 2. So if R is equal to 2, okay, I've got my sequence here. 4, 5, 6, 7, 8. I can work out the sequence here, and I can use a formula to work backwards. I can just count backwards. This is going to be 4.5, 2.25, and if I want to find the sum, I now have my A equals 2.25. I have my R, I have my N, and I can just do this calculation. Okay, so this works out to be 2 to the power 5 minus 1 times 2.25. Okay, so I get 69. The total sum ends up being 69.75 is the sum of the first 5 terms. And if I actually wrote out the first 5 terms, okay, so I'm going to get 54, 63, 67.5, 69.95. Yeah, it all works out. Here, this is an infinite series. Okay, my A value is 8. My multiplier, I can see that my multiplier is going to be, well, what is it, my multiplier? 16 over 3 divided by 8 is me 2/3. Yeah, so my R value is less than, and that's less than 1. So that means that it's a decreasing series. Okay, my multiplier is less than 1. It can go infinitely, so I have a formula for that. My formula is just the one I learned. A over 1 minus R, 8 over 1 minus 2/3. That becomes the infinite sum. If I add all these terms together infinitely, I'm going to get a sum of 24. And again, even if I just add the first 3 terms, looks like I'm going to be getting towards 24. Okay, so well, it's going to take me a little while actually, but so if I can just keep on adding those terms, generating the series, adding them up. Okay, so I guess technically I should have probably put pluses in here to show that we were actually adding up that series. Okay, so these are some main ideas. We have our sequences, we have our series, and we have our infinite series. Those are some things that we want to be thinking about when we're preparing for these assessments.